The most helpful thing for me for this problem was honestly just to solve it multiple times. But yeah, so this is a sliding window problem. You have a left pointer and you want to move the left pointer anytime your window exceeds the constraint that you need your substring to have at most k replacements, and all other characters must be of one character. And anytime that constraint is not met, then you're going to have to shift your left pointer to a new window where that is met. So we can start by also defining a result variable. My right pointer is just going to be the I in this for loop. The first thing we want to do is create a count hash map. You can also do this as an integer array of length 26, but I find it a little easier just with a hash map. Also, it does save a bit of memory because you might not necessarily use all 26 characters, but it's a very small difference, so really it's just up to you. The first thing we do when we're inside our for loop is we want to add the count to this current character. Remember, it's important to know the max count of the most frequently occurring character inside our window at any given point, because this will tell us if our window is currently valid. We can basically do this in Java by first checking if our count contains this character. If it does, then we just want to update its count and increment it by 1 because we're seeing this character right now. And otherwise, we just want to put it with a count of 1. Okay, and then now we want to update the we want to find what the maximum occurring character is and what its count is, and this will be important to tell us if our window is valid. So we're gonna loop through all of our hash map. And we want to update max to be what the frequency of the maximum occurring character within this window. So that is our current max. Now, the important thing is to check if our window is valid. So we can first find the length of our window, which is going to be I minus left plus 1. And then we want to know how many replacements we need to make, which is going to be what this is minus max. Because now, when we subtract it by max, all these remaining characters are going to be characters that are not the same character as max, the max character, so we're going to have to replace them. And if this number is greater than the number of replacements we can make, then we're going to have to shift our left pointer up. But before we shift our left pointer up, we had to update the count hash map, because when we shift our pointer, we're going to have one fewer character. When we shift our window, we're going to have one fewer character than we previously did at the left pointer. Alright, and then here we just want to, now that we verified like our window is valid, we just want to find the max of what our result currently is and what the length of our current window is, which is going to be I minus our left pointer plus 1. At the very end, we return result. So this should work. But there's actually a slight optimization you can make. So you see here that we are manually computing max every time. We could actually just update max to be the max of itself and what the value at the right pointer I is, like this. And this should be like marginally faster, but the difference is pretty minimal. So, oh, never mind. Um, oh yeah. Yeah, there we go. Like it's a pretty marginal difference. I think the other one's like beats 9% or something. So it's just a really small optimization.